Hello everyone, welcome to my new video. In this video, we'll start by solving exercise 1.1 from your NCERT textbook. This is session number 2 in the entire series of the sessions of the chapter number systems from your class 9. Okay. In the previous session, we discussed about how to classify numbers into different categories, how to say if a real number is a rational number or an irrational number, and how to categorize further rational number into integers and non-integers, and how to really differentiate between if a number is rational number and irrational number. So if you haven't checked out my previous video where we discussed those things, please do so. All right, let's continue with the exercise 1.1, question number 1. So in this question, they say, is 0 a rational number? Can you write it in the form P over Q, where P and Q are integers and Q is not equal to 0? Now, is 0 a rational number? So yes, it is a rational number. Why it is a rational number? We already know that 0 can be written as 0 over 1, which means 0 can be written as P over Q, where P is equal to 0 and Q is equal to 1. So therefore, 0 can be written in the form P over Q, and I should say where P and Q both belong to integer. Remember that integers are represented with Z and Q is not equal to 0. So Q cannot be 0. If Q is 0, then that P over Q is not defined, and we don't want the number to be not defined. So we want to make sure that Q is not 0, which in this case Q is 1, so it is not 0. All right, since 0 can be written in the form of P over Q, which is 0 over 1, um, where P and Q are both integers and Q is not equal to 0, therefore 0 is a rational number. Okay, so since 0 can be written in the form of P over Q, which is 0 over 1, where P and Q belong to integers and Q is not equal to 0, hence 0 is a rational number. That's the property of a rational number, that a rational number can be written in the form of P over Q. All right. Also remember that 0 is a whole number as well, and it's an integer as well. Okay. All right, let's move to problem number 2 from your this exercise. They say find 6 rational numbers between 3 and 4. Now, whenever they say find some rational numbers, whatever a number of whether they say 6 or 7 or 10, doesn't matter. Find whatever rational numbers between two numbers. The most effective way to do this is I first write those numbers down. So I need to find 6 rational numbers between the numbers 3 and 4. Now, since I need 6 rational numbers, take any number which is greater than 6. Let's say I take 7, right? Or I could have taken 8 or 9. Take just any number really which is greater than 6. So I took the number 7, right? So now multiply and divide by 7 to make this 3 as 21 over 7. Do the same thing here. 7 over 7. So 28 over 7. So now basically those 3, that 3 can be written as 21 over 7. That 4 can be written as 28 over 7. Now, if you want to find 6 rational numbers between 21 over 7 and 28 over 7, now those numbers are basically 22 over 7, 23 over 7, 24 over 7, 25 over 7, 26 over 7, and 27 over 7. Okay, so these are your 6 rational numbers between the numbers 3 and 4. Okay. Now, this is just one way of solving this. If you think about it, between 3 and 4, there can be infinite number of, uh, also just to confirm, this is your answer, okay? Um, but just to clarify and give further understanding in detail, between 3 and 4 or between any two numbers, there can be infinite number of rational numbers possible. So for example, you could write between 3 and 4, you could say 3.1, 3.2, 3.3, 3.4, 3.5, maybe 3.6. These are six rational numbers. Or you could have said 3.11, 3.23, 3.56, 3.78, and so on. So there can be really infinite numbers of rational numbers which are possible between 3 and 4. Okay. Now your question, is this is a decimal number? Is this rational? Yes, it is a rational number because I can write 3.1 as 31 over 10, which is like P over Q, where P and Q is integer and Q is not equal to 0. Okay, so remember that there are infinite number of rational numbers possible between any two numbers. Okay, but I think for just for the uh, perspective of solving this question, that's the answer. Okay, 20. That's the most effective way, which is why I said there are many different ways to kind of get the rational numbers between two numbers, but this is the most effective way of getting the rational numbers between two numbers. Okay, let's move to next problem number 3 from the same exercise. Now they say find 5 rational numbers between 3 over 5 and 4 over 5. Okay. Now, the most effective way I find is just write those numbers down, 3 over 5 and 4 over 5. Now, since I want 5 rational numbers, just take any number which is greater than 5. Maybe let's take 6, right? Now, multiply and divide by 6. So, multiply and divide by 6. So, that means this 3 over 5, you could write it as 6 times 3, 18, 6 times 5, 30. And here 6 times 4, 24, 6 times 5 is 30. Okay, so basically those 3 over 5, you can write that as 18 over 30, and that 4 over 5, you can write it as 24 over 30. Now there are a lot of many possibilities of writing rational numbers between 18 over 30 and 24 over 30 really. So maybe if you want to write 5 rational numbers, just maybe so between 18 over 30 and 24 over 30. So remember denominators are same. So you can just write 19 over 30, 20 over 30, 21 over 30, 22 over 30, 23 over 30. You can keep going, but you just need 5 numbers for now. So these are 5 rational numbers between 3 over 5 and 4 over 5. Okay. Remember that denominators must be same in order to use this trick. Okay. All right. Now let's look at question number 4 from this exercise. They say state whether the following statements are true or false, and we have to give reasons for those. Question number 1. They say to see if this is true or false. Every natural number is a whole number. Okay, now let's see. Let's first write the natural numbers. So we know from our previous video that natural numbers are the numbers starting from 1. So 1, 2, 3, 4, and so on are natural numbers. We know whole numbers are the numbers starting from 0. 1, 2, 3, 4, and so on, right? So let's say this is equation 1. Let's say this is equation 2. So that's the set of natural numbers. If you just add 0 to the set of natural numbers, we get a set called whole numbers. Now, we can see from here that all these natural numbers, 1, 2, 3, 4, 5, 6, are in fact present here in the whole numbers. So all these natural numbers are present in this set of whole numbers, right? So we can see each and every natural number, 1, 2, 3, 4, 5, 6, and so on, is will be present in this set of whole numbers, right? So therefore, we can say from equation 1 and 2, from equation 1 and 2, all natural numbers, all natural numbers are whole numbers, or every natural number is a whole number. All natural numbers are in fact whole numbers. Okay. All right. Let's move to question number two. Question number two says every integer is a whole number. Uh, let's see if it's true or false. To start this, let's first write integers down. We know integers are denoted with Z, as we discussed in our previous video. Okay. Now, integers contain positive numbers, negative numbers, as well as the number zero. Okay, so the positive numbers 1, 2, 3, 4, and so on. Negative numbers -1, -2, -3, and so on, and the number 0. Okay, so that's the integers. Now let's see again the whole numbers, right? Because we need to see if every integer a whole number. So let's see the whole numbers. So if we write whole numbers down, the whole numbers are 0, 1, 2, 3, 4, and so on. So now the question says, is every integer a whole number? Now let's look at all the integers. Uh, there are some integers which are whole numbers, yes, not all, but there are some 0, 1, 2, 3. So all these are whole numbers. So that's whole numbers. But is it true that every integer is a whole number? Is -1 a whole number? No. Is -2 a whole number? No. So none of those negative numbers are whole numbers. Yes, 0 and all the positive integers are whole numbers, but not the negative ones. So what do you think about this statement? Is every integer a whole number? No. Every integer is not a whole number. Yes, there are some integers which are whole numbers, but not every integer. Okay, so we can say, let's name those equations as 1 and 2. So let's say if this equation 1, equation number 2, we can say from 1 and 2, every integer is not a whole number because integer contains negative numbers as well. Integer contains negative numbers too. And negative numbers are not whole numbers, but integer does contain negative numbers, which then tells me that every integer is not a whole number. So therefore, every integer is not a whole number. Okay, so therefore, statement 2 is false, because in the statement number 2, they say every integer is a whole number, but that's not the case. Every integer, we found out, is not a whole number, because integer does contain negative part of the numbers as well. Okay, so the statement 2 is false. Okay. All right, now let's move on to question number 3. Question number 3 says, identify if it's true or false. Every rational number is a whole number. Now we know rational number contains all integers. There are some non-integers as well. Basically, rational number is a number that can be written in the form of P over Q. So every rational number is not a whole number, because rational number does contain decimal numbers too, like 3.1, 3.2, 5.1, 5.2. There are some negative numbers as well, basically all the negative integers plus the negative decimals and so on. So every rational number is not a whole number. So let's write that down. So question number three, rational numbers are the numbers in the form, or that can be written in the form P over Q, where P and Q belongs to integer and Q is not equal to 0. Okay, so therefore, rational numbers does contain non-whole numbers, non-whole numbers too. So since rational numbers are the numbers in the form P over Q, that means that rational numbers does contain the numbers which are not whole numbers, of course, because whole numbers are just 0, 1, 2, 3, 4, and so on. But rational numbers does contain many numbers outside of that set as well, right? So therefore, um, we can say all rational numbers are not whole numbers. Okay, I hope that makes sense. We can say statement number three is false. All right, I hope that's very clear now. All right, that's it for exercise 1.1. We solved every question in exercise 1.1. Thank you so much for following me thus far. If you have any questions at all, as always, I'm always there to help you. Please feel free to ask your questions in the comment box. Please do like the video, subscribe to my channel. All right, thank you very much. Have a great day. Thanks, guys.